preparing to live stream the meeting.
Yeah, you got it. You got it.
Really? Are we on, gentlemen?
Yes.
Yep.
Yes.
We can go as I live and breathe, and as all of us, we're so happy to be living and breathing. We are the members, ladies and gentlemen of the board, and the hardcore supporters of our Central South Coast longtime astronomy and telescope club, the Santa Barbara Astronomical Unit. And I'm Ron Herron, your host. This is the SBAU Astro Hour, weekly online vlog podcast, if you're only listening, using Zoom, focusing on some of the latest space news and discoveries, cutting-edge cosmology, hardcore astrophysics, and featuring some of what I deem the brightest, most knowledgeable minds in Santa Barbara, California, if not the world. Very proud to be among you guys on the Astro Hour. We meet every Monday morning. This is number 178. It's for the week of July 22nd through the 28th, 2024, and I think we're on YouTube. You can link.
I'm checking right now.
Are we on YouTube?
Think so.
And one of our gentlemen I'll introduce you to here in a minute is probably going to watch, as you notice somebody missing from the screen, but here what we're going to talk about. Let me just give you a couple of quick headlines. Firefighters managed, we believe, to save the Astro observatories over at the Sedgwick Reserve near that lake fire in our county, including LCO's burn scope and the UCSB telescopes. Going to be talking about telescopes this hour. Last week, New York Times sent this out on Wednesday. A meteor came in over Manhattan, about the size of a toaster, and exploded. And boy, did they know about it. We missed a part of that anyway. Here's what we're talking about this hour. The gang that's left. A couple of major telescopes have shut down their offices totally. I thought they were moving to Texas with Elon. Space bubbles, multiple big bangers or big bangs. We're going to talk multiverses. Could be infinite. Whoa, heavy stuff. Most of space is very cold, but wait till you hear about the cold spot. Globular cluster Omega Centauri. It's got a black hole in the middle. My God. We're going to check out a couple of NASA probes. Juno going around Jupiter and the Parker coming in close to the sun. Speaking of the sun, a sunspot sending out a solar flare. And we could have a big crowd thanks to the LCO and their speaker on the night of the 2nd, Fleischman Auditorium. It's Museum of Natural History, where we do meet everybody. Let's meet the gang. Jerry Wilson, our president, is on assignment, checking out his birthplace and seeing what night viewing is like in Western Europe. His wife is Pat Forgy, but he may be watching us finally now. Chuck McPartland's on screen. He's married to a Pat. He is the most outrageously outreachable SBAU outreach coordinator we've ever had. He's the heart and soul, he and Pat, of our club. Tom Whittemore joined us. He's married to Maureen, and I guess the monthly newsletter is his response. Incidentally, Chuck's wife, Pat, is our merchandise manager and new treasurer, and she's doing a great job, and that's got to stop. Chuck, would you pass that on to her? Tim Crawford, married to Karen.
Hi.
He's going to be wandering in the world of cosmology with me, asking the questions, and seeing if we can do this without Jerry. And Tom Totten is our Mr. Spock of the Starship SBAU. The commander. You notice he's got pointed ears.
Mm-hmm.
Needs to be green.
And Baron, yes, we are live on YouTube.
Are we really?
Yep.
That means that we may have some people watching us. There certainly is a black cat somewhere. Whoa. Listen, we got lots to talk about, but we always do the silly science cartoons that are sent to us by President Jerry, and he has left us with a bunch that Tom Totten is going to throw on screen, and we're going to check out some of the sillies getting this. Okay, this is some NASA soap opera stuff. I think these are either astronaut wives or astronaut groupies. One of them telling you, looks like a Far Side. One lady consoling the other on the couch. I'm so sorry what happened. And she goes, he said he needed space. Oh, Janet, it's not easy dating an astronaut. He happens to be up in the ISS right now. And that's something you rarely see. This one I didn't get. You're going to have to explain. Unless
I kind of got that. All
right. It didn't say what word has 4 letters, so maybe it's something else. Are we talking about male?
No, look.
The sign above. Look at the sign above.
What has 4 letters? Okay, the word what has 4 letters.
Oh,
the word sometimes has 9 letters.
White Heart.
Crying out. You know what I came up with? 9 letters is astronomy, but the short version of astronomy is Astro, which is 5 letters, so that wouldn't be it.
That's another answer.
What the hell is White Heart? Does anybody know what that is?
That's
It's a
a
deer, a
cigar
white
pub.
deer.
That's a pub.
Oh, it's
That's a pub
here?
name.
This was taken here in town?
No, this is probably somewhere in Great Britain.
Right. Yeah,
In
probably
fact,
a
the
pub.
White Hart, I think that's in Bath, England. There's a pub with that name, and when we visited and went to the Herschel Museum, that's where we had dinner.
Are they misspelling heart? Is it like
No, H-A-R-T, Hart. That's a deer.
Right. Stag.
Oh,
kidding?
really?
I
I didn't know that.
learned so
Didn't
many
know
things.
that.
All right, here are these
Yeah,
soldiers in wherever ancient times gathered at the desk. At the desk, they're at the
Castle.
castle, which is being run like a business office. You can never get past that receptionist. You got to make an appointment, guys. I'm sorry.
Monty Python there.
This one we've had before. If you were
Yeah.
the 7th planet out from the sun, or the 3rd from the right, and you didn't have a good name, let's say your name was Uranus. You'd want to change to Doug. No one was really surprised when the 7th planet changed his name, but we got it covered. Now this one I think I figured out. Tried donating blood today. Never again. Too many stupid questions like whose blood is it? Where did you get it? Why is it in a bucket? Type A, B, A, or O, or
Yeah, well, it's probably a mix. Yeah.
yeah. And here is a 1-cell organism taking its cell fee using a microscope. Do they have little cameras in those suckers?
Yeah, oh, yeah.
Man, Hook would be proud. That's funny. Finally got the spelling. I thought it was misspelling. We're wandering through the research lab, and there on the wall is the safety record. This laboratory has worked 10001 in 10,001 days without an accident. She says to her fellow technician, it looks very impressive till you realize we use binary numbers.
Well,
that
what
should
is
be
that
all.
equal to? What's that equal to, Ron?
10, 12, 11, 8, somewhere in there.
It's 17. So
Is that 17?
the first one is in the 16 column, and then the last one is in the ones column. So
Yeah. Good.
So
17.
1 by itself would be 1, but 11 would be 2.
Well, 11
No,
would be
not
3.
binary.
11 would be 3. And so if you had 1 1, that'd be 3. But if you had 1 1 1, you'd have 4 plus 2 plus 1, that'd be 7.
Mhm.
And then the next column is 8s, and then the 1 is in the 16 column there.
Well, no,
Right,
I was going back to the very beginning. Forget the first one, the 10,001, just 1 by itself. That is 1. And then 2 would be just 2 ones.
No, 2 is 1 0.
Yeah.
Oh, 10.
Yeah.
Yeah.
Oh,
Right.
Yeah. There's no 2 in binary, Ron.
Yeah.
I didn't say there was a 2, but what represents number 2 in binary?
1
Right.
0.
1 0.
1 0. Then 3 is 1 0 0, 100.
No, 3 is 1 1.
Oh, then it goes, geez.
2
Okay.
plus 1, 3.
And your computer understands this, and it's all going away the day quantum computers come around.
Hey,
Okay.
Ron, just to get back to heart, for a second. So my mom was born in Hartford, Connecticut, and that's where the deer crossed the ford in the river. That's where actually that word came from. Hartford.
Is that right?
Cool.
Yeah.
This one is new. I didn't see this one.
Yeah, neither did I.
A chef is talking to a ding dong, or I'm trying to get hired. The resume. He says, "You're applying for waitress." You should know no hostess. Okay,
That's pretty good.
All right.
It's a chocolate Twinkie. I see. Okay. I don't know where you got that one. Did that come to your house, or did you dig that up, Tom Totten?
No, it was one of Jerry's, so
Jared, yeah.
I put that down.
All
I
right.
didn't get it, but there was one of his where I couldn't read the graphic, so that must have been that one.
Okay.
Well, Tim Crawford has the talking points on his screen. You want to just open by reading a few of the lines, and then we'll take over from there.
Well, one of the things, Ron, that you can talk about is the Orion and Meade
Telescope.
closing, and that's that's going to be followed by our cold spot in the universe. And
Yeah,
Like,
and it's not for sure that they're gone for good, but It looks bad for Orion and Meade, and actually Orion owns Meade, so it's really just sort of the same company that's having whatever problems it's having.
So we're showing one of the classic Orions. It looks like an 80 millimeter scope.
ADED, that's the ADED. And that's not the short tube 80 that was real popular, but the ADED was real popular as well.
Yeah.
Or it might be 85.
No, it's 80.
It's
80 ED.
Okay.
It's just using the fancier glass, so there's less chromatic aberration.
Yeah, it was a doublet, but
Yeah.
but fancy glass.
But they don't come with support legs?
Well, that's a tripod. You can put it on any tripod.
Oh, okay. I'm wondering if these brands aren't sort of the Studebaker and Dodge Omni of the telescope world that just went away because of new designs of other companies that outsold them.
This is more corporate shenanigans. Meade was deteriorating over the years. They were one of the big sellers, but their products were going downhill, and especially their customer service. They were putting plastic gears in their drives that were wearing out. They were stopping support of models after only a couple of years, and you couldn't get spare parts for them if things broke. And they moved manufacturing to Mexico, and then they were bought by some Chinese company, and the Chinese company was engaging in some shady corporate price fixing things.
And the company was called Sun Electronics. It says Sun Electronics.
Yeah. And Orion used to sell Meades, and so they ended up suing Meade or suing Sun Electronics, and they ended up getting a judgment where they basically ended up buying Meade as part of the process. And that might have been biting off more than they could chew.
I think that's what happened.
That's
what happened.
But what we're looking at there is all lenses, right? There's no mirror in this.
Right.
item?
Right.
Say,
That's
Chuck,
a refractor.
Chuck, was Chew spelled CHIU, incidentally?
Yeah.
And nobody in the club has any of these?
Oh, yeah.
Oh, no, this is a picture that Jerry took in Australia with his Orion ED, I believe.
Yes.
Yes, that's exactly right.
Jerry went to Australia?
November 2012 from Queensland, Australia.
Yeah.
He went there just for this eclipse?
Yes.
Yep.
Well,
He and Pat, and they were out in a big field. And what they didn't realize was it was a field where they grazed cattle, and so there were a lot of landmines that they had to avoid.
Yeah.
And they set up,
right.
and there were clouds until like the last minute, and then they cleared and they got a nice eclipse.
Wow.
And I assume we got none of it, not even a partial up
No,
here?
not here. Yeah.
No. Look at those prominences.
Ron, we had a partial eclipse in California. The total eclipse. Oh, in 2012, I'm not sure what happened there. Were they down in Australia? It didn't touch us at all in 2012. Yeah.
Okay, got it. That's quite a way. That's 12 years ago, for crying out loud.
So one bad thing about Orion going away is, for years they were sort of owned by somebody who had started the company, and it's not like they manufactured a lot of their own stuff, but they had a really good reputation for having good value for money. And they also had super customer service. And if you called them up, they wouldn't try to upsell you. They would tell you, oh, that's too much, this would be a more budgetary, reasonable thing for you to buy. So they weren't out to kill you. And they were company owned. I mean, the company was owned by the employees, and they grew and they grew and they grew, and they had open stores in other places. It used to be just up in, I think, Watsonville or
Right, Chuck, if I might just add, yeah. So their main facility was in Watsonville, but they had a dynamite little store over in Cupertino.
Okay, yeah.
Near where I taught at De Anza mathematics for a little while, and I used to go to that store. And in fact, I bought, I think, my Celestron 9x63 binos there. It was a really nice little store, wonderful staff. I'm talking a long time ago. I'm talking probably about 1994, 95, something like that.
They also carried a line of, I think, Vixen eyepieces that were really good for the money.
Did they ever do telescopes with mirrors?
Sure, yeah,
Oh,
they
yeah,
did beads
sure.
and they made their own reflectors and stuff, or sold their own branded reflectors.
Yeah.
That's the SkyQuest Dobsonian, like Tessa has, and they made little mini Star Blast Dobsonians that were like petting zoo scopes for kids.
the Star Blast was popular not only with kids but with adults because you could set them on a picnic table. They were unbelievable.
Yeah,
Well, you know, we have the Orion 14-inch Dobsonian in the shed that was donated by Charles Schuler, a 14-inch, and a Telequest one, I think it's called. What's it? Tele something that has, you can get it set up so you can go to find things easier.
in telescope, yeah.
I thought Dobsonian was a brand like Orion.
No,
What does that
no.
mean?
No, it's a style of a telescope, the way it's constructed.
Oh, named after
And-
somebody named Dobson.
John Dobson.
Yeah. And Orion, you know, then just this last couple of years since some of this fiasco started, their customer service went way downhill, and that's usually a bad sign. And so hopefully they'll resurrect themselves. And I guess they must not be employee owned anymore if the employees are getting locked out and there's talk of bankruptcy. So,
Oh boy.
Well,
All right.
somebody looted it, you know, capitalism at its best.
yeah. I know we brought this up before, and I thought I had it explained to me. Anytime we have a 90-degree turn, so you're looking in the side of the scope, the back end, that involves an angled flat mirror, doesn't it?
Uh-huh.
And a
Or a
reverse.
prism.
What?
Or a prism.
Or prism system. Mhm.
So it's not a reflective, it's all within a prism, a triangular piece of glass,
It can be.
angles. Do you get a reverse image always?
The prism, you can get a normal view, a non-flipped view, but the mirror gives you a flipped view.
Yeah.
Okay.
And Ron,
Yeah.
you know what a prism is?
I
That's where they keep criminals.
knew it. I knew it.
Folsom prisms. Okay,
Yeah.
got it.
And
There
on
it
that
is.
note,
Yeah.
let's talk
CMB.
about the multiverse.
Yeah.
CMB stands for cold microwave background.
Cosmic microwave
Oh,
background.
cosmic.
Cosmic,
I'm sorry. And there it is, the round part in the lower right.
Yeah.
So they have a detail there.
Mhm.
Okay, and you can see the scale down there at the bottom of this, the little explanatory thing is microkelvins.
Yeah.
Okay.
Oh my
These are
God.
very small temperature variations in the early universe when it became transparent to radiation. And so those are basically telling you where there were concentrations of mass and energy and where there were voids. And there's this big void down there, that CMB cold spot, that statistically is out of place relative to the rest of this graph. And one, you know, highly theoretical bit about that is this could be where our universe bumps up against another one that's budding off of this multiverse.
Okay.
One of the things that confused me about this image was that it looked to me like that over at 3 o'clock, 4:30 in this image, there's just as cold as spots, and I didn't get
and very big. Okay, but they're looking at the more detailed statistics somehow.
Okay.
See how there's much darker blue and it's very concentrated in there in that little S
Right.
shape. Yeah.
Right. The reverse question mark. Yep.
Yeah.
So blue is on the left side of that gauge, that graph on the bottom, and that's the coldest. That's absolute zero, right?
No.
No. These are microkelvins, Ron.
These are microkelvins relative to the overall temperature.
Right.
So you're looking at variations, not at absolute values.
So variation of 3 degrees Celsius, you think?
No. It's
Oh, no.
minus 400 microkelvins in the coolest spots relative to that 3 degrees.
Yeah.
Right.
So the scale, Tom, runs 800 microkelvin from left to right. Okay. But if you divide that by 1,000, like 0.400, that's
Yeah.
still in millikelvin, So these are really phenomenally sensitive detection schemes they're using to get this microwave background.
Yeah,
What
that's really
instrumentation do they use to measure this sort of resolution on temperature?
Yes.
It's the Kobe, satellite and the follow-ons to that.
Yeah, the Planck, I think, right, Chuck?
Yeah, and the
Planck.
Wilkinson
Well,
Microsoft
yeah, the
microwave.
WMAP.
WMAP, yeah.
But
So it's microwave radiometers and really, really sensitive, and they
Yeah.
scan the entire sky.
the entire sky. In other words, that whole oval represents the globe around us, or the
Yes.
interior of the sphere that we live in, all the way
Yes.
to the edge.
Yep.
And the
Okay.
lighter colors would be galaxies.
No. Well,
No,
okay.
they may-
On this scale, those are huge clusters of galaxies.
Yeah.
Of course. And the blue obviously represents the interior or the inner space.
No, that's more voids where there aren't big clusters of galaxies.
Yeah, right.
Or there weren't big. Okay, when this happened, there weren't galaxies yet. This is just where there were concentrations of energy or lack of energy. Because right when this happened, did you just get mass? I guess you just had mass. E equals mc squared, so it's all kind of the same thing. But this is where the universe became transparent to radiation. So
Right.
this is where you finally had, I guess, electrons combining with protons to form hydrogen.
Right.
Atom.
So you could see the early universe. So
Yeah.
this is about 380,000 years after the Big Bang, just roughly.
Okay. And this
Oh.
And the temperature of the universe is ballpark at that time about 4,000 kelvins, just roughly.
So that's like the surface of a red giant star.
Exactly. Yeah. But we can finally see through the fog, through that fog.
When the electrons weren't coupled with the protons, they interact with light, and so that
Yeah.
makes it so that it's not transparent.
Right. Just
So you
scatters
can't
it.
see past that barrier.
Right. Mhm.
So you want me to read about what the professor said about the cold spot?
Sure.
Yeah.
It
Please do,
says,
Tom.
here we go. We cannot entirely rule out that the spot is caused by an unlikely fluctuation explained by the standard model. But if that is not the answer, there are more exotic explanations. Perhaps the most exciting of these is that the cold spot was caused by a collision between our universe and another bubble universe. If
Wow.
further, more detailed analysis of the cosmic microwave background data proves this to be the case, then the cold spot might be taken as the first evidence for the multiverse, and billions of other universes may exist like our own, he said, Professor Tom Shanks.
Mhm.
Wow.
The problem is, since they're in another sort of space, this is like the only evidence you'll get of them.
And they were kind of hinting that it maybe in a parallel universe or be some kind of like a gel that would be thinking the same thoughts we would be thinking. Weird stuff.
What doppelgangers? That means
Yeah,
exactly.
maybe someone's trying to send us a message there. That letter S, what's that stand for?
Yeah.
Wow.
All right.
And the Planck Institute is one of the people that were backing this survey.
Yeah.
Discovered it.
This is an amazing image. This web. Wow.
Is this
Pillars
the
of creation?
Pillars of Creation?
Pillars of Creation in the Eagle Nebula. This is the Webb view as opposed to the Hubble view.
Yeah.
Could also be called the fingers of the witch.
Well, also at Halloween, they put this up as a dragon.
Mm.
If you rotate it kind of a little bit more toward the right, you got a dragon wing at the top and a dragon head there.
Yeah.
A dragon wing down at the bottom. So
It looks like dragon teeth right here to me.
yeah.
So
He's
Wow.
about to spit fire.
So it's dust and gas with stars in the middle, right?
Stars forming all through it. Yeah.
Mhm.
Some of which you did not see at all with the Hubble image.
Yeah.
Because this is
Really?
peeling away different layers of dust at probably different physical sizes and temperatures.
Right.
Look at
Ron-
way up at the top. It looks like there's a ghost up there.
Yeah.
Uh,
And Ron, from the
with two
diffraction
eyes.
spikes, you can
Right-
tell this
right
is
below
from a
the hand there.
segmented mirror.
Say that again, Whittemore.
Oh, I was going to say from the diffraction spikes, you can tell that this is from a segmented mirror and not the Hubble. The Hubble's a single 94-inch mirror.
Well, it'd be the web, wouldn't it?
Yeah.
Oh,
It's the
yeah,
Webb.
this is definitely the Webb. Mhm.
Well, it seems to me there might be more to this that we don't see to the lower left off the picture. Like maybe I'm thinking of a hand, but I don't know. Is that the
Oh.
extent of the nebula? What
No,
we're
no,
looking
there's
at?
a lot more nebulosity down there. This is just looking at the pillars, since that's that, Hubble picture that's sort of iconic.
Is there a scientific explanation for why they're projecting out in big long columns? Why wouldn't
Yeah,
they
it's
just?
because there's dense areas at the ends of those fingers, and they're blocking the radiation coming from stars off to the right that are eating away this cloud.
Oh,
Those are like umbrellas on the finger tips. Think of it that way.
okay.
Huh.
And
Which-
what's really amazing, okay, is a bunch of people in our club now have these little sea stars, 50 millimeter lenses. I mean, that's less than 2 inches.
Right.
And when they focus on this Eagle Nebula, like when we were at Kachuma, you're in a dark place,
Mhm.
you can see the pillars of creation.
That's
I mean, this is
amazing.
a little dinky telescope with a lot of processing inside, and it's showing a macro picture of this. It's much smaller, but you can make them out.
Mhm.
But now the horse head isn't part of this. It's
No.
somewhere else, isn't it?
That's in Orion.
Mhm.
Okay. And this one is in what constellation? The pillars.
It's near Sagittarius, but it might be in
The Eagle Nebula.
yeah, the Eagle. I think it's in Sagittarius.
Yeah, I think that's right.
Or
Oh my God,
Aquila.
look at-
No,
So
no,
Ryan,
it's not in
you're
Aquila.
asking about more of the same there. So let's say this image here
Mhm.
Wow.
shows a much wider area of that.
Yeah.
Look at that.
Ah, look at that.
And
Jeez.
again, this is Webb.
Mhm.
Right. Yeah, you caught that.
Can
That's
imagine that being
amazing.
used in science fiction stories as a photo.
Why
Wow.
am I doesn't
Mhm.
zoom, either goes back and forth
Warp,
or
warp speed, engage.
Yeah.
And all the
that's not what
stars,
we're doing.
all the stars suddenly become blurs like we're going that fast through the stars.
Wow.
Wow, that's fascinating stuff, gentlemen.
Mhm.
All right, next thing is Omega Centauri. Here, let's see if I can get
All
there.
right.
And share this
Okay.
back and go here. Oh, so we're showing where Omega is in the Centaurus constellation somewhere. I think I have a
Well,
better image.
we see it in the backyard here, but kind of like in May and possibly early June.
Yeah.
It just comes up over the Channel Islands here.
It's barely above our horizon. Yeah.
Yeah.
Okay,
And-
here's the green. This is stellarium.
There
Here's
you
the
go.
green
There you go.
horizon line here,
Mhm.
and this is 8 o'clock. What? 8 o'clock. Oh, it's been going today. I don't want that. I want to go back in time to
Yeah,
for tonight.
it's long down.
Let's go.
Kind
to
of
the
peak
sky.
time here is in May, just roughly.
Hmm.
And it's real,
Right-
it's pretty
right
bright.
here.
In binoculars, you bring it out pretty easily.
So
Yeah.
what's this centaur doing? He's half horse, half man.
Mhm.
He's spearing a wolf.
Oh yeah, poor Lupus is getting knocked there, isn't he?
Yeah.
There's
Mhm.
a scorpion, and we got what's this snake called? Hydra.
This Hydra.
And then we got Corvus the crow and
Crow.
Crater.
Crater the Cup.
So but
Had
see, it's right. So Ron, that you can see this globular cluster, Omega Centaurus, is really close to the horizon. So you have to
Yeah.
have a really good view over the ocean.
Mhm.
Tom has that. He's always telling us about that, and we're
Right,
jealous.
and Jürgen Hilmer loves this thing. He can see
So-
from where he lives.
So if I center it, and then
If-
we zoom in with
If
stellarium.
this were up higher in the sky like M13, it would outglow it. This is
Yeah.
really big.
And this is actually closer. It said only 17,000 light years away.
Yeah.
Okay.
And it's you'll see numbers now. The previous numbers I was seeing were 2 million stars in this cluster, but now you've got people saying 15 million, which I think
Yeah.
might be a little
Oh.
overestimate. But
Yeah.
still, it's pretty dense. It's got a lot of stars.
Mhm.
We think it's the core of a dwarf galaxy that we've gobbled up.
Mhm.
Ah,
And they just found an intermediate mass black hole in the middle of it.
is that right? It's like a mini galaxy, isn't it?
Exactly.
Yeah.
And Ron, the NGC on it's 5331. NGC 5331.
Oh, is that
Yeah,
right?
So
Yeah,
Messier
what's
did
his face? Messier could never see this. It's too far south, where he lived.
Now, how do they know there's a black hole?
So
Look
what
at
they
see
did,
it, you can see it right there. You can see the black hole.
yeah.
See a black hole.
what they did, telescope, you got fancy telescopes now that you can resolve the core of this cluster. And just like with the black hole at the core of our galaxy, they found a bunch of fast moving stars near the core that are orbiting this object.
So all those telling us you'll never be able to see a black hole is total lie, because they all have accretion disks. So you'll see where they are anyway.
Not all of them, but you can see the ones that do have it. Plus, you can see their effects on what's around them.
Right.
Is this a supergiant black hole or just a black hole?
Right.
It's an intermediate mass black hole, like 2,500, was it?
I think it was 8,000, I think.
Okay, solar masses.
Oh, okay.
So if that star cluster has 15 million stars, it might have had 17 million at one time, or 18 million. And that's now, the rest of those are now in that black hole, right? It's sucking up its own stars, isn't it?
Or gas, yeah.
Or
it would have made stars.
And how close can stars get if they're not binary?
They can collide in these things. You see
Okay,
what are called blue stragglers inside of globular clusters, and they're anomalously bright and young looking. And that's where two lower mass stars have collided and merged.
I've gotten that question at outreaches, Chuck, and I didn't know that answer. Thank you. That's people ask me, like, how close did they get at the core? And I said, well, it may look like they're all bunched in there, but there's really a lot of distance between. And that's
in general, yeah.
So you want me to read what the text said around these photos here?
Sure.
Here we go. So to determine what lies at the heart of Omega Centauri, Halberer and his colleagues turned to star tracking. Taking 20 years of publicly available Hubble Space Telescope images, the researchers followed the paths of 1.4 million stars, gee, that's a lot of following, located in the globular cluster. They then determined each star's so-called proper motion, which is a measure of how much its apparent position in the sky changes because of the star's motion relative to the sun. Analysis of the star's proper motions reveals 7 stars moving at anomalously high speeds. These stars are all located within 0.26 light years of the center of Omega Centauri and are moving so fast that if the cluster contained no black hole, they would have escaped its gravitational grasp long ago. Using data from the 5 fastest moving of these stars, the researchers calculated the on-scene mass needed to keep them in place, putting it at a minimum of 8,200 times the mass of the sun. This value lies securely in the intermediate mass territory. It's one data point, so we can't make any broad conclusions yet, says Professor Halberer, about the intermediate mass black holes in general, but it shows that we can find them this way. So that's the story.
That sounds really tedious way of finding it, but yeah.
Just look at 1.4 million stars.
Yeah. And find the 5 fastest.
A quarter of a light year apart, most of them, you said 26.
Yep, a quarter of a light year. Yeah, amazing. All right, what's this?
Well, that's got to be Io.
That's Io.
Yeah.
The little
volcano.
Yeah, you can see the plumes on the limb there.
And this was taken. This is somebody used data to make this picture.
Sure, that's what all pictures are.
Yeah.
But it was a citizens. It was a citizen scientist, Andrea Luck, made this image from the raw GenoCam data.
Wow.
So
yeah, and they put that available on the web for download by the public right after they take the images, right after they get sent here. So you get a lot of people making cool pictures of the cloud tops on Jupiter and things like that. But this time they went by Io.
And it says the satellite was 2,400 miles away at the time.
Pretty close.
We're looking at 2 blasting volcanic eruptions high in the distance.
Yeah.
On the curved horizon. What is going into space? Lava?
It's sulfurous lava. So sulfur ions and all kinds of stuff in that.
It says mission scientists think the plumes were emitted either by 2 vents from one giant volcano or 2 volcanoes near each other.
And you can see
So-
some of the other vents down here in the rest of the picture. Those big black areas.
Wow. So it's like Venus without an atmosphere.
Yeah.
Amazing.
Very
Some of the
interesting.
pictures I've seen of Io in color make it look like a pizza.
Cheese pizza
Cheese pizza, yeah.
with some mushrooms.
I thought that these plumes were really cold, but they're not, huh?
No, not on Io. Those are the plumes on Enceladus that you're thinking of, or in Europa.
Okay,
Ice
maybe
plume.
it's Europa. Okay.
Yeah. Those
I
are
don't imagine-
cryovolcanoes.
Don't imagine
this-
NASA plans to land on this little dinky moon anytime soon.
They've been talking about it, but you got to choose carefully.
Well, is the whole surface hot, do you suppose?
At least near these vents. Yeah, it's the hottest place in the solar system outside of the sun.
Is that right?
So-
Even hotter than Venus?
Yeah.
So what do you think? Is it the tidal forces of Jupiter pulling on this moon that's about the size of our moon? Is that what's going on?
And the other moons, yeah, in synchrony with it. And these volcanoes were predicted by Stanton Peele at UCSB before they were found, because he realized you'd get this dynamical frictional heating of the interior.
Yeah, I thought Venus was the hottest. This is hotter.
Yeah.
Huh.
But
I mean, overall, Venus is hottest, the whole planet, but this has got hotter hotspots on it.
And Io is the innermost of all its moons, right?
Of
Closest.
the 4 big Galilean moons.
Right.
Oh, are there moons closer?
Yeah. Adrastea or something like that. There's another moon, at least one
So
other
Chuck-
closer.
Chuck, what's the
Amalthea?
number? What is Jupiter up to? The number of moons now?
95.
Only 95?
Only 95. Saturn's at 146.
Oh, okay.
Jupiter has rings too. You don't see them as good as Saturn, obviously, but I wonder if it has shepherd moons in its rings.
It could.
Are they on its above its equator?
Yes.
Anytime you have rings there, so the moons are all in the same ecliptic.
Not all of them, but the Galilean moons more or less are.
Yeah, Tom, what is the tidal? There's a word for that tidal friction.
Yeah,
From-
tidal force.
Yeah, that
Well-
causes.
Close enough. I would think that says it all.
Well,
Tidal
you might be thinking of resonance, where their orbits or their orbital periods are like integrally related.
No, I'm talking about where the planets, where the moons get really, really hot from the tidal forces of the planet nearby.
Yeah. Well, not necessarily from just the planet, but from the other big moons that are also in synchrony with it.
Yeah,
They're pulling in all directions,
I
kind
thought
of.
there was a name for that causes a temperature. I'll look it up sometime. I know that there's a name. I'm blanking on it.
Well, the term I've always seen is tidal dynamical friction.
Okay.
Well, tidally locked means that probably Io is always facing Jupiter too, wouldn't you
Yeah.
think?
Most moons in the solar system are tidally locked.
Is that right? Out
Yeah.
to a point though, after really?
Yeah.
No matter where they are?
Yeah.
What are we looking at here?
The rings of Jupiter.
These are the rings. I thought they were little skinny things.
They are.
Well, they looked like an invisible Saturn.
Yeah, very tenuous.
Wow.
And they call them gossamer, Skinner.
Yeah. There's a hint. Okay, so
And what's
there's Amalthea, Adrastea, and Metis in there. So those are the really innermost moons, and Phoebe. So you can see they're kind of acting like shepherds.
Evie, Metis. Wow. These names come from ancient Greece, ancient Rome, Shakespeare. God knows where they come from.
Yeah. Oh, here, yeah, wow.
What is that? What are we looking at here? Jupiter.
Still the rings.
Standard
And they're
image.
showing, I'm not sure what they mean by a standard image sensitivity, and then they go all the way up to 390 times sensitivity. I'm not sure what they're saying there.
Yeah.
Well, all 4 of the gas giants have rings. Obviously, the most predominant are Saturn, but is that the remnants of an expired moon that just couldn't keep up and decided to fragment out in all?
Well, it could be a moon that got within the
Roche limit.
Roche limit. Yes, thanks.
Mhm.
And the tidal forces ripped it apart,
Mhm.
or it could just be debris that never formed into a moon.
Yeah, these were
Okay.
first seen by Carolyn Porco when I think it was the first Voyager rolled by.
Mhm.
Huh.
And you can see also it could be from impacts.
Mm-hmm.
Oh, like a meteoroid. What the heck's a meteoroid as opposed to a meteorite or a meteor?
Oh, a meteorite is when it lands on the ground. A meteoroid is the thing that makes the meteor. And the meteor is just the glowing air that you see when it gets ram heated by the meteoroid.
So that
Oh.
satellite is turning into a ring because of the meteoroid.
The meteoroid is blasting debris off the satellite and it ends up in a ring. Yeah.
That's probably what happened on Saturn big time.
Yeah, there's so much there that was probably an icy moon that got in the Roche limit.
And maybe some of the bigger pieces became shepherds.
Yeah, that sounds good.
That Cassini really gave us a lot, educated us.
Mm-hmm.
Yeah,
Fascinating
it
stuff,
gave us
gentlemen.
dumplings.
Yeah. Okay, what's next, Mr. Substitute Commander
All
Totten?
right. Let's go to the next image here. Oh, looks like Parker.
Oh, Parker.
Oh my God.
Parker probe.
4.5 inch thick. What's it called? Carbon something or other keeps it from.
Carbon composite.
I thought carbon was very flammable. You would think that
You
sixth
need
element.
oxygen.
Oh, it needs oxygen. Okay.
Hmm.
And that none of the oxygen isn't coming out from the sun's surface with all those other things.
Nope.
Wow. It's how
So
close is it gonna come
it's
in?
at its second to last perihelion, closest approach to the sun. It'll sweep within 5.3 million miles of the sun this time, and bringing it ever closer. Its final approach will be 4 million miles from the sun. And you got to figure the sun is about 1 million miles in diameter, so
Almost 800,000.
yeah.
It even says in there it's going to sweep with inside the corona at one point, isn't it?
Well, it's up. We're inside the corona. So is it.
We're inside the corona of the sun.
Yeah.
Mm-hmm.
Just because all that debris comes out, all that space, what's it called?
The solar wind.
Solar wind, that's the word. So
So
what's it
Chuck,
going
you're
to tell
saying
us?
that if we're inside the solar wind area, that means we're inside the corona. Is that what you're saying, Chuck?
More or less. Yeah.
Well, wouldn't you think it'd be very difficult to transmit any radio waves back to us? We're going to have to do it after the fact, right? When it gets way out in their elliptical orbit away later to.
No, you can do it from when it's as long as it's not behind the sun from our point of view.
Really? That much stuff coming out of the sun. Parker. We don't know who Mr. Parker was. I'm assuming he was an astronomer.
He was a solar astronomer. Yeah.
Okay.
You know, it says it has 26 planned perihelions, but it's only going by Venus like 7 times. So, uh, does that, what does that mean? It doesn't go out to Venus sometimes,
Well-
but it still comes back down, or?
Well, it goes out past the orbit of Venus, but Venus isn't in that position.
Okay, but
it
sometimes they
getting-
use Venus to redo the
Oh,
orbit.
Yeah, to
Right.
change the velocity or reorient it.
yeah, it's getting the gravity assist.
Yeah.
Okay, slingshot.
Well, in this case, they were using it to slow down. Because when you're
Oh.
heading toward the sun, you're falling downhill and the speed just starts building up. And so you go by these planets to slow down so that you can go into orbit around the sun,
Oh yeah.
the orbit
yeah.
that you want.
And they're gonna crash this into it eventually, right?
I don't know.
Well, now it's
Send it back
connected.
to Earth.
Yeah, there's a part of that green line that's connected to our orbit. Is that the launch from
Yeah.
us?
Yeah. Mm-hmm.
Okay. It's not coming back, but it comes pretty damn close to the orbit.
Or it did.
Or did.
Yeah, getting closer and closer to the sun. Yeah.
Isn't Mercury's orbit similar, although not quite as radical? It's sort of an ellipse, isn't it?
Yes.
Mercury.
But there you see it's not that elliptical.
No,
It's
but
most elliptical of the planets, but it's not a real super ellipse.
Yeah, I think they're showing the sun. The yellow dot in the center is the sun.
apparently
Well,
apparently this is the way it's done on our probes. It was the way Cassini went around Saturn, and it's the way Juno is doing. It's coming in for close calls, going real fast, and then going out because there's danger in being close, isn't there?
Right. And that's why the Juno probe is like that around Jupiter,
God,
because
you
of
know
the
what?
radiation fields.
You can't just orbit above like ISS does the Earth.
Were they ever considering some kind of a probe picking up samples of something? Is that
sun?
even? Is
Well,
that,
they're kind of measuring it. I mean, it's not like you could easily return this stuff. It's very tenuous and
yeah.
tough to get back, to climb back out here.
But obviously, whatever it's measuring has to be done through that heat shield, doesn't it?
Yep. You got to peek around it or through it.
Boy,
Huh.
long way to go to check out a charcoal briquette.
Yeah.
Is this the first time we've ever orbited the sun with a probe?
No, I mean, we're orbiting the sun, so are all the spacecraft orbiting us.
Not a probe.
Yeah, we have the stereo satellites out
Yeah.
there that are in front of the Earth and behind the Earth. Is that right?
No, they're on the other side of the sun from us, and so you can get some idea what's coming
Okay.
Oh,
as far as sunspots.
interesting. I didn't know that.
All right, to the moon.
Suddenly we're on the moon. Okay.
So
Where
this
are
was
we?
like July 25th, and Jerry had this photo trying to emphasize the scattering of stuff on the moon. So this is the waning moon.
Like a Copernicus and then Tycho. Tycho at the bottom. We had a really good view of that.
Yeah.
Mhm.
Yeah, with the full moon, we were really seeing all the splashes.
Yep.
Clavius is my favorite.
And
This
then
is
let's go ahead.
This is an image by his Facebook friend here,
Okay.
Jerry's
Okay.
Facebook friend.
Oh,
Oh,
really? Okay.
This one? Oh, this photo was the taken by NASA. It says a visualization studio. The next one is, I think,
Yeah,
one
his buddy.
yeah.
Okay. Messier.
Oh,
gets
one
his
with a
name.
12-inch mead like we have in our shed. We have 2 or 3 12-inch meads, and the lunar reconnaissance orbiters on the right.
Wow.
Two
And
different
talk
shots.
about Messier.
Yeah.
Messier got his
And
name on the moon. All right.
really strange about it is what hit, how it got created. This actually is one object created both these craters, I guess.
Mhm.
Really? How would they know that?
They did a trick. They actually did a laboratory, and they tried to imitate exactly the way this pattern showed up. And they could make one object. Hold on, let's see. I didn't want to do that.
Must
I
have
guess
been-
I'm still here. Okay, I'm still in this, but I wanted to find my other image of the Messier things.
But this
All right.
was obviously a grazing impact.
Mhm.
Now those,
Right.
Tom Cotton, on the image on the left, there are those streaks that are coming out of the crater. Are those
Mhm.
just debris that?
Yes. Splash marks.
Okay.
And because of their
Wow.
orientation, that's hinting at the low angle impact.
Yeah.
Now-
Yeah.
Now
Okay.
put your 3D glasses on, and you'll really see that this is real. I have this. I have the 3D glasses, and it really shows what's the depth of this thing. So the meteor was going from left to right to make that groove, I believe, the way that worked.
Have you ever
But,
skipped
it's
a flat rock on water?
Yeah.
yeah. I think that's what kind of happened here. It said 1 to 5 degree angle coming in, so really low angle, and so it passed across and left. Yeah, where's the center of the meteor that got left? The asteroid that got left. Where would they find that?
Yeah. If it didn't vaporize.
Ooh, is that possible? Just vaporize and leave these craters?
Yeah.
Or it could have left a whole bunch of them, just like a rock does. I can make them skip 8 or 9 times back in where I grew up. Slate,
Yeah.
Wow.
It's tougher on pavement.
And, we'd gone through all the ancient names, and they decided, why not just give it to old Charles Messier?
No, the names of the craters on the moon are scientists who studied the moon.
Is that right?
Yeah.
Okay. But the Mares aren't. They're named for something
Mares
else.
aren't,
Utility.
So this is a picture taken by Apollo 15.
Look at that.
That's the Tunguska of the moon.
Then LRO, and then the stereo view from Apollo 11. That was a Apollo 11 picture that they had a stereo view of the craters.
That was going from right to left or left to right there?
Back
left
here
to right.
again, I think left to right. Yeah. And Rima, oh, they call that the Rima Messier. That's from Lunar Orbiter 5. That are they talking about this
Yeah.
At Long Valley.
rill? Is that a rill? Is that what they call it?
Yeah.
I don't hear the term rills used on this show much. But they represent what? Long canyons?
Yeah. Yeah.
Pretty much.
Now,
Tributary.
would that thing been created by a big rolling rock?
That's probably more like a collapsed lava tube, if I had to guess.
Really? Okay.
The Rima.
Do we have something positioned in place 24/7 that records the moon in case something hits? We won't
Lunar
miss it.
Reconnaissance Orbiter, LRO.
Well, that can be only above one part at a time.
Well, any orbiter that applies.
But if it happened on the other side of where it's orbiting, you wouldn't see it.
Yep.
Where is the moon? What phase is it in right now?
It's heading toward third quarter. That's why we're looking at third quarter images here.
That's what third quarter is, right?
And that triplet there at the
Last
terminal,
night it was a little fatter than that, Ron.
that looks like the Theophilus and Cyrillus and Katerina.
No.
Yeah, that triplet.
Is that it? Yeah.
On the limb
That might be them.
on the Terminator.
Right there.
And the Apollo 11 landing site is just about to go in a shade. It's farther down. That's Sea of Serenity up there. There it is, right near your cursor there, just to the left, where you got the little Pac-Man mouth coming up to grab the little white cookie.
You have a better eye than I do.
Tom, are we going to be able to go from this to back to the solar flare?
Right
That's
here.
the next event, yeah.
Okay, we had a flare event. Speaking of
This is
Parker
July
Probe.
16th.
Okay, what happened? Did it affect us?
Radio
Yeah.
guys, ham radio, yeah.
I was going to ask that. Ham. It said shortwave. Is that ham?
Yeah.
Okay.
I mean, there are probably hams on all kinds of wave bands, but traditionally it was shortwave.
So does this showing that it was centered over the Atlantic Ocean somehow?
Yeah.
When it impacted?
Yeah. Ionized the atmosphere and messed with how things reflected.
It was on the side of the sun going away from us, wasn't it?
Well,
go ahead.
It's showing megahertz down here, but what got affected megahertz wise?
Yeah.
0 to 35.
And you see it's protons, Ron. So when they're belched out of the sun,
they go in all directions.
The sun is rotating, so you get like a spiral effect of the magnetic field lines, and they spiral outward like in a sprinkler pattern following that. So they can hit us even if their initial vector was not directly towards us.
Protons.
Yeah.
Are there electrons in that soup as well?
Probably, yeah.
But they just don't get together and make atoms.
Right, because they're moving too fast.
Is that right? Okay.
So how dangerous are these X-ray fluxes here?
I don't know where it gets dangerous, but you wouldn't want to be up in the ISS and not in the safe room, probably.
Yeah.
What's the name of the event in the 1800s that killed the telegraph?
The Carrington event.
Was that one of these?
That was a really super duper one. Yeah.
And they come out of sunspots.
They're associated with sunspots, yes, because that's where there's intense magnetic activity.
As opposed to prominences, which are something totally different.
Yes. The thing people see in pictures that looks like feathery extensions off the edge of the sun, like you can see around here, those are prominences. They're not flares, but people call them flares.
They're like big expanding blobs or rainbows that break open or bubbles or whatever. Okay.
Yeah.
I've seen,
Whereas a flare is like an explosive bright event that doesn't last nearly as long. Those are plages that you're seeing there. So those are areas around sunspots in this wavelength.
I don't suppose the Parker was coming in for a trip around the sun about the time this sucker went up.
That might have been bad news for them if it happened.
Maybe so. Maybe it wasn't. It was out by us by that time. Fascinating. What's the lower right mean?
This is
solar cycles. And they're
this
showing.
is a it's a
go ahead.
butterfly diagram, it's called, and it shows you where the sunspots have been appearing. And so they start at high latitude and they work their way down to the equator.
Wow.
And so you can see we're in cycle 25 right now, I think.
Yeah.
But the other cycle is already starting, I guess. Or did I get that wrong? Do they start near the equator? No, I think they start near the poles and come down.
It shows that you can guess too.
And
I think you're right, Chuck. I think they do.
Yeah, so that's it. That 26 question mark. You can see that could be the potential start of the next solar cycle already.
And then they reach the equator and then cross down.
Yeah.
Well, they come from both the south and the north of the sun, and the sunspots start towards the mid latitudes, it looks like, and come down towards the equator over the solar cycle.
Yeah, and then it restarts out at the poles.
Yeah, so it jumps. Yeah, interesting.
And the sun rotates pretty much like the gas giants. The different levels go at different speeds, and somehow it doesn't get all twisted up. Man, alive.
Right at the equator, I think the sun's rotation is like 25 days, and then at the north and south poles of the sun is maybe like 35 days.
Yeah, is that right?
You know that large heart they found on Pluto? This looks like two hearts lying on their side that are full of squiggles. You know what, gentlemen? I learned a lot. Jerry, we don't need you.
Oh yes, we do. That was all Jerry's work picking that up there.
I totally.
He sure got the timing. You guys got the timing perfect.
Yeah, well, we're out of it, and he's probably in deepest, darkest. Where is he going besides Ireland? He's going to be in London, isn't he?
I think he flew first to London, and then they're going to Dublin, and then they're going to go to Burcastle, where Pat and I went in September. And then they're going to go to another observatory at a castle, I think, farther north in Ireland.
What an observatory. You pay to get into those? Is it like Mount Wilson here, you suppose?
Burcastle, yeah, you pay to go in and wander around, but it's beautiful surroundings, and they got a pretty good museum, although their astronomy part of their museum could use a little bit of an astronomer to curate it, because they didn't even spell Messier right.
There was something outside that you saw, Chuck, that was an M51. It was a big tree or something.
Yeah, so Burcastle is where Lord Rosse had the world's biggest telescope for like 70 years. And it's a 6 foot across mirror, this gigantic telescope that's out in the grounds of the castle. And he saw the spiral arms in M51. They didn't know it was a galaxy. It was just a spiral nebula to them. And in the park around it on the grounds, they actually have topiary. They have trees that they planted in the form of that spiral, so that if you're in a plane or happen to have you happen to have a drone up above and take a picture, you can see the spiral structure.
That I thought was really cool.
But just like you and your Pat, he's not going to leave his lip DNA on the Blarney Stone.
Oh, look at that. Wow. That's
there's the telescope.
I'll be darned. An ancient
one.
To
get that aligned though. I mean, you're only looking at one area of the sky, but look at the big cables coming off of it to lift it up. I mean, it's really
So it's looking at the horizon, or it's just laying down?
Right now, it's
Lays
looking very low. Yeah.
Well, he's going to be gone for 4 weeks, and we're going to get a lot of good stuff from him when he gets back. And I guess
They also have the
this-
LOFAR there that Tom showed briefly.
Look at
What,
that.
what is that called?
The LOFAR, it's a low frequency, like a microwave telescope
Huh.
or
He
free
set
or
that back up in
radio
the
telescope.
1800s.
Yeah. That's a new addition.
Well, gentlemen, let's do it again in another episode. Number 179 will be next week, when Tom Totten will be commanding our Astro Hour unit again. The president is on assignment. Tell your friends about us.
We got Telescope Workshop on Tuesday evenings,
That's
7:30.
tomorrow night, right? And next week will be the 29th, Monday the 29th, end of the new month, end of the week of next week will be us and probably a good crowd at Fleischman Auditorium at the beautiful Santa Barbara Museum of Natural History. Join us every Monday morning, 11 to noon, on the SBAU Astro Hour. Ron Heron on behalf of the guys, thank you. We'll see you at the next one.
Everybody.
Week.
Bye-bye.
Thanks, Ron.
Bye.
Bye.
We miss you, Tom. We miss you.